Hello guys and welcome back. In this video I wanted to talk about float, vectors, and integer and make sure that everybody knows what they are, and then I'm going to explain how to write a simple Vex code and basically show what we're going to be using the wrangle for. So we have first thing, we have integer, and this could be 1, 2, 4, 500, anything that doesn't have decimals. Okay, so these are all integer numbers. And for example, one instance where we find these integers is the point number. You can see each one of them is a unique integer number. So that's integers. And then we have float, that is a number with decimals. So we can have something like that. We can have pi. We can have anything, and these are float. It could be the x position of the coordinate, it could be a uv, the u dot x, for example, the v coordinate or the u coordinate. It could be the height, could be a noise map, for example, black and white noise map. That's all float data. And then we have vectors that are made of 3 floats. So float 1, float 2, float 3, and these are called x, y, and z. X, y, and z, and that's how we refer to them. So for example, the position is a vector, and it's made of 3 components, x, y, and z. So for example, these guys, they have a point position. If we right click here, you can see it's px, py, and pz, and these are the coordinate of each point. Okay, each point has a value that places it in space. So let's talk about some math function now, and these are the 3 things that we need to know about in when it comes to numbers and vectors. So let's say we want to create a new value here, for example, that is equal to the point number of the points. So let's create an attribute wrangle, and this is where we can type Vex code. And Vex code is the Houdini native language for manipulating data in SOPs. So I'm going to connect this node, and we can access the any attribute and override it with a new value. So I can say v at p. This first is the type of the attribute that you either want to declare or access. So in this case, we want to access the position, which is a vector, so it starts with v. If it was a float or an integer, we would start with an f or an I. So vp at p, this is the at syntax to tell Houdini that we either want to read it or create it if it doesn't exist. I will want to change this value, okay? And it's going to be equal, we're going to create a new vector to override all the points, and we need to use the keyword set to tell Houdini that this is a vector. So I'm going to set the points to be equal 15, something like that, and we need to end with a semicolon at the end, and that finishes the syntax, the first syntax. Now all the points are getting the same coordinate, they are all being overwritten. So if I click here, you can see those are all the points on top of each other. And if we right click, these are the position. Okay, all the points are overwritten. But let's say we don't want to override, we want to add this as an offset. So let me change this to be 5 on the y-axis, so it moves the point up. But I don't want to override the points, I want to add to it. So we're going to take this vector and we're simply going to add to it. So v at p is equal v at p plus this new vector, and that will move the points up. Okay, and we can change this back 1, we can set it to 0, and you can see the points are moving. Cool. So let's say we have we want to create a float, for example. We can do f at my attribute. This is the name of the attribute that we want to create, and it's equal a random number. And this random number is a math function that, given any input, any value, it's going to give you back a random value between 0 and 1. Okay, it's called a random function. And what I want to do is I want to use the point number here to generate a random number. You can see this, each one of them has an ID, and I want to use that to generate a new a random number. And the way to access the point number is using the @ptnum syntax. The @ptnum is a built-in Houdini function, and now we're it's working. If we right click, we can see that it's created this my attrib here, and we have all the values randomized between 0 and 1. Okay, now let's say I want to visualize this number. We can view it using a built-in feature of Houdini. If you have anything on the geometry that is called CD for color, it will get visualized here. Okay, last time I think, yeah, we placed in a color node, and let me change this to 0, for example, or let's pick a different color, something like that. If we middle click, you see it created a CD attribute. This is how Houdini determines the geometry color, and you can turn this auto display feature by right clicking here and turning this off. Now it will ignore the geometry information. So let me delete this. I will want to plug this my attrib value into the color. Okay, so let's say v at cd is equal at my attrib. Because it's already it already exists, I don't have to prepend it with an F. And you can see now we have the color displayed on the points. Let me increase this. That's my that's the point. And again, it's random, so it's not gonna look smooth or have any pattern because it changes based on the point number. Now let me reduce this back to 1. Now we generated a float, and we overwritten the C all the 3 values of the color, which is a vector. So we've overwritten the green, the red, green, and blue. And you see here it says RGB. It's basically X, Y, and Z, or 0, 1, 2, and those are the vector, the float of the vectors indices. So I don't want to override all of them. I just want to override the red color using this float. And the way to do that is using the dot syntax in vex. So I can say from this vector I only want to override the X component, and if I do that, it's going to assign the information to the X channel. Now let me set the color to black because it's additive. Okay, and you can see now we're only adding the red channel, a value to the red channel. Okay, all the green and blue are still 0. Okay, let's continue. I want to copy this. I want to create a new random value to use for the green and blue channel. And instead of calling it my attrib, I'm gonna call it green. And let's call this red. Date it here. Cool. And right now, the green color is generating exactly the same result as the red because the point number is the same. And think of this as a seed value. So you give the random function a specific input, and it gives you back a result. If that input doesn't change and you call it multiple times, give you back the same result. So we need to change this value, point number, by adding an offset to it. So it's, let's say, 0 to 99 here, or how much we have. It's a lot. So 2500. Yeah, 2500 points. And we can add an offset to them. So I'm going to say @ptnum plus, let's say, 100. Just adding an offset to that. And now the green value is going to be different from the red. And I want to plug in this green. So I'm going to say v at cd.y is equal at green. Okay, and now we're plugging in the color into the green channel, and you can see it's not overlapping. So if I remove this offset here from the point number, you can see it's on top of each other. The result is the same. But if we add an offset, it's going to generate another random value, say something like that. Cool. So the other thing, if we right click here, you see that these green and red attribute are being added here, and we don't want them. We don't want them to be stored at the point. I want them to be local in the scope only. I don't want that attribute, the green and the red, to be added. I just want the color to be modified. So to create a local float or a local variable, we're going to create we're going to use a different syntax where we say the type float and then the name. In this case, I'm going to call it blue, and it's equal a rand at ptnum plus 660,000, for example. And this float blue, this syntax here, if I middle click, it's not adding it. And the way we declare local attributes is by using the full name of the type. So vector x, for example, is equal set of 1, 2, 3. Okay, and this vector x here is not getting added here. It's local. We can create an integer as well using the integer int keyword. So int equal 155, and again, all this code is local to this guy, so it's not getting added. And I'm going to delete these two guys, and for the float here, I'm going to overwrite the v cd.z is equal float, blue. And because we declared it, we don't have to prepend it with anything. Houdini will automatically recognize this because it's a known word now. You can see it's working. Now see this syntax here, I don't like this 3 lines, and I'm going to change all these to local as well. So float red, green, and blue. And instead of doing this, I'm going to say v at cd is equal, and I'm going to build the vector on the fly. So green and blue, and these are my 3 components, and now the same result we have. Cool. So with this, we can also do all kinds of processing. For example, we can say the blue is equal to the red minus green multiplied by 2 plus this random number. So we can do math operation here and subtract and compute all kinds of values that we need. Okay, so that's our first function, and I'm going to create a different object, and I'm going to explain something else this time. So I'm going to create a sphere, give it a radius of 10, and if we take a look at P here, you can see each point is 5 units away from the center. If we right click, you'll see that it has, it should be 5. Oh, sorry, this is, yeah. Let me change it to a polygon mesh, and it should be 2.5. Why is this? Yeah, so it's 5 units away on each axis, and depends on the position. It's going to be 5 on one of the axes, and then something else on the other values. So each point is has a vector that is enough to move it from 0, 0, 0 to here, and that is equal to the position vector, which is the vector needed to move a position from 0, 0 to this location, okay, or this location. And I want to display that vector. I'm going to use a wrangle node. I'm going to plug it into the normals. So v at n is equal v at p. This is a built-in function of Houdini, and the v normal is an attribute that normally exists on any geometry, especially for rendering or anything like that. And this is the we're using this shortcut to preview a vector, in this case the position, as the normal. Okay, by default, to create the normals on a mesh, we use a facet node and tick on post compute. Now if I view it here, you can see that's the vector of the mesh. Now don't get confused, I'm just using this visualizer here. I'm overriding the normals with the position. Okay, so each point it now is displaying the position vector, and you can see how it's pointing. We can flip it to see the proper to see where it's coming from. So let's multiply it by -1, and it should be going in. I don't know why. Yeah, so that's the vector going towards the center, and we can multiply it by 100, and that should make it longer. Too long. Cool. So you can see they're all reaching towards the center. Let me clip this geometry so it's easier to see the vectors. Okay, so now we have a half a sphere, and let's set this to 4, 3. And you can see the position is all aiming towards the center. Okay, now what I want to do is I want to compute something called the length of that, which returns how far the point is from the center. And to do that, we are going to use a function called length. So we don't need this. I'm going to create a float called length, and it's equal to the length of v at p. And this is a math function that will, given any vector, it's going to compute the length and return the correct value. And for the length, we should see 5, because that's how far each point is from the center. Okay, and you can see it here. Cool. Now if we, for example, let's increase this. And let's create another point somewhere else. Okay, now we have added a point. And what I want to do is instead of using the position, I want to compute a vector between the position and this guy. So I want to create vectors from here aiming towards this guy. And the way to do that, the easiest way, is by connecting the second input, the point into the second input, and now we can access its position. So second point, let's call it vector second, or goal, let's just call it goal, is equal to point 1, I'll explain this why, v p 0. Okay, well, what is this? What we're doing is we're telling Houdini to give me the point attribute. Okay, this is the point syntax. Give me the point attribute of the input number 1. Okay, this is number 0, this is number 1, this is 2, this is 3. And you can see 0.3. And it's saying also ancillary input point parentheses 1 ... So you can access the information from here. Okay, now how much points do we have in this input? We have 1 point, and the number, the ID of that point, if we look at it here, it's number 0. And this function, we tell it where to read the data in, what the name of the attribute is, and the ID of the point we want to read its value. So now we're importing the point number 0 position value, okay, and we're storing it into this goal here. So what I want to do next is create a new vector, and for now I'm going to just store it into the n attribute so I can visualize it nicely. So v at n is equal to the v at position minus the goal, and this is going to create the vector aiming towards the points. Now it's flipped, so we need to change flip these guys. It's the goal minus v at p, and now you can see they're all pointing towards that point. The length is not correct in this case, and we can change that by going under the settings. You see here it says scale normal. Right now it's scaling it by 80%, so I'm going to set this to 1, and now we're getting these vectors in there. So if I move this point, we're getting the vectors pointing towards that point, Let me reduce the number so it's easier to see. Okay, let's continue. Now with this, each one of these guys have a different length. So the points that are here, they are 2 times further away than these points. Okay, and I want to compute the length of this new vector. And at the moment we're calling it, we're plugging it into the normal, so we can just compute the length of that. So let's call it f at length is equal the length of the normal. And let's see what we get. So now we have a value of 6, value of 15, and it's changing 15 all the way to 6 here. And let me keep this open. You know what, I'm gonna split this and have the spreadsheet always open. So we can do it like this. Okay, and right click and the geometry spreadsheet, and now we should be able to every time we select an input, we're going to view the values. Cool. Let me move this down so you can see the length here, and if we change the point, let me select this and I can pin it so it always shows me that result, and I can move now and you can see the length changing per point. Now let's say I want to let me increase these guys. Let's say I want to use this length and view it as the color. So let's v at c is equal length. Okay, and we need the syntax at because it's an attribute. So let me hide this, and you can see the color now changed to white. And let's get this closer, and there we go. The closer it gets, the darker. And right now it's not showing the colors because they are it's fully white because the colors are going all the way up to 15, and that's not something that we can visualize. We can only visualize between 0 and 1. So what we need to do is we need to take this huge range that goes from 0 to 15 and remap it into something smaller that is that we can visualize. So what I'm going to do is I'm going to use a function called fit that can do exactly this. So I'm going to fit this huge range that goes from 0 to 15 into 0 and 1. And the way this function works is by giving it the attribute first that you want to fit, its original range, which goes from 0 to 15, and then the goal that you want to remap it to. Okay, so now we're remapping that between 0 and 1. And let's move this point. Where is it? Yeah. And you can see we're getting we're overriding the normals. That's why the display is changing. So let me set this to flat, and let's select the point. And you can see where it's close to the surface, it's gonna get black. And then when it's far away, it's going to get white. So let me first override, set the colors to be black to start with, and then we should be able to visualize this better. Now you can see the range here. I want to flip this. I want to invert this this data. So in the fit range, I'm going to change it to 1 and 0, and it will be white where the point is close to the surface and black when it's far away. So I can do this. Okay, cool. So that's how you use the length function. We use the fit function, and we use the point to access the attribute. Cool. I think this is good enough for all the fact stuff that we need. I don't want to overcomplicate it more than this. In the next video, we're going to talk about some math function and then get started. Thank you guys for watching, and see you in a bit.